We want to introduce you to our research, which is done within the research project POTENCIES. In this research, we made a study about the correspondence of active reading, co-design, and social robotics. And on the right side of the slide, you can see the poster, which was advertised for our study, which was done within the Museum of Contemporary Art this April. So here is a slide for our another collaborator. So obviously we have Professor Indulkia, who is present with us today, but we also used help from Professor Schaper from University of Barcelona. So in our study, we wanted to see how the presence of social robots, such as now, will influence the activity of active reading and co-design, and these terms will be introduced later on. So, like as you can see on this slide, we used the now robot, which is designed and made for the interaction between, for the interaction with human participants. And in our study, we decided to go with the Wizard of Oz methodology. So this paradigm assumes that the participants are convinced that they are interacting with the autonomous robot, while in reality, the robot is operated by the programmers or by the researchers who are not visible to the participants. They can be behind the curtain or in the different room. So in our study, we had a following procedure. So first, we wanted to see what kind of attitudes towards robots have the participants before the direct exposure, so hence the pretest. Then we moved forward to active reading. Then we wanted to see how this active reading influenced the attitudes of the participants. So we repeated the test in form of post-test, and then we went to the co-design workshop activity. So our participants were two groups of children, school children aged between 10 and 12 and 6 and 7. So the first group was international students from Kraków. They have background from like very diverse background in terms of culture. And the second group was the Polish children from Kraków. So here you can see the small insights towards the setup of the study. So you can see that the children were sitting on the floor on the pillows, and the educator and now were on their eye level. So it could allow the more like direct contact. In the background, you can see the huge screen, you might see the huge screen, which was the content of the book presented. And on the left side, you may see, hopefully you can see the glimpse, there is a curtain. And behind the curtain, our programmers, Karolina and Alicja, were sitting, listening to the course of interaction. And because during the active reading, kids were asked to perform multiple tasks, they were also sitting in these small groups by the desks, and they were doing some craft activities. So during the pre and post test, we used the methodology of monster game, and I will show you the example in a minute. So on the left side, you can see the presentation. One of the researchers were doing this presentation. So they were saying, okay, let's imagine that you have two characters. One is the lion, the second is the monkey. And now you have to mark on the questionnaire that you have in your hands, with whom do you agree more? So the first character would say, I think a robot could be a great artist. And the second character would say the contrary statement. And then children would have to mark either monkey or Leo statement. And then after the pre-test, we went to active reading activity. So here you can see on the picture, even you can see how it looked like. So basically, our educator Anna, she was reading the story of two friends. One is imaginary friend, and another is a lonely boy. And Anna was also doing the characters or doing the narration of the story. And from time to time, children were asked to do some interactive activities, such as playing charades. So, for example, in the book, Fred and Sam are fans of playing charades. So here, children were asked to play with Now as well. And for example, Now was performing some movement, and then kids had to guess what kind of movement was that. And they were doing turns in that activity. Also, Now was interactive in the way that it took turns in reading. For example, Anna was providing the narration, while Now was reading the voices of characters. After active reading activity and doing the post-test measurement, we move forward to the co-design. And co-design means that we were trying to engage participants in creating something together. So here we had this idea of asking children to create a book for robots. So we would ask them, can you please try to design and deliver a book that will be interesting for Now? And to do so, first we asked them to draw their favorite moment of the interaction. The idea behind this was that we wanted to see how often they would actually draw the Now presence. So we wanted to indicate whether it was interesting for them or not. Second, we provided them the examples of book. Here we wanted to see, we wanted to show them that the idea, the concept of book is not fixed, it's fluid. It can be, for example, a hardcover book, it can be audiobook, it can be ebook, or whatever they can imagine. And finally, we'll ask them to do the design of the book for robots. And here you can see some pictures of that activity. And this is some of the examples of the ready product. They had only like a limited time, so an hour or something like that. So obviously it's not done perfectly, but you could see the ideas behind this process. Okay, now we can introduce you to the data analysis and our results. So as I mentioned, we wanted to see how the attitudes towards the robot changed before and after the interaction. So you can see different form of evaluation of that concept. First of all, there is this pre-test and post-test about children's perception of the robots, which example is the monster game, so the thing that I mentioned before with the lion and the monkey. And then we also did this post-interview, so we asked them to draw their favorite moment, and then we wanted to perform some semi-structured interviews where the children explained their drawings and experiences during the workshop. And just like a small insight towards our monster game results, we realized that it's a very handy tool. Nevertheless, younger kids, especially below 10 years old, seem to not understand the idea. They often marked 2 answers instead of 1. Sometimes the attributions of the answers seemed random. So it is good to consider different form of evaluation for children below 10 years old. Also, we had some interesting insight towards the co-design activity. First of all, older children tended to work in teams, so and also they were more focused on tasks, so they actually delivered a book instead of simply doodling, which was pretty common performance of the younger children. Moreover, we realized that the previous experience affects the mental image of robot. So, for example, if a child is from the household when one of the parents have a work related to robotics, they were more aware about the mechanism behind the robot. So they were saying stuff like, the programmers did the best they could, robot was fine. So it was like awakening for us. But what is really interesting that this experience did not discourage them for willingness to create a book for robots. They were still engaged into this interaction. Also, age seems to be more crucial factor than being a student at international school. We want to also put some more attention towards the background of children. So whether it's like previous experience with robot, international education, or maybe the job of their parents, and how those factors influence the interaction. And also what was quite surprising for us is that the children took different approaches towards created books. So one group delivered audiobook, the second one delivered book in a robotic language. So it's also very interesting how they perceive the capability of robot and how the robot can comprehend given book. Okay, that's all from me. So I will.
Okay. Thank you. So my name is Alicja, and I was one of the programmers of the robot. And in my analysis, I decided to define children's mental model of social robots, or at least try to do it. So basically, to find out how children do perceive and understand robots in general. And to do that, I decided to use the Godspeed scale of human-robot interaction measurement, which is a scale that consists of those 5 dimensions that are visible on the board. So first one is anthropomorphization of robots, meaning that people, or we want to find out whether people do or do not assign robots some human-like characteristics. Second one is animization of robots, which means assigning robots some characteristics of live organisms. Also, likability of robots, meaning the degree to which people do or do not like the robot they interacted with. The intelligence of robots perceived by people who interact with it, and the feeling of safety in the robot's company of the people who interact with such robot. And the data that was analyzed were mostly statements of the children concerning the robot or robots in general, and some of their behavior towards the certain robots that they met. And those data were collected during the whole activity, both the interaction and the co-design part, where children could refer to what they did before and tell us more about the robot and their feelings towards it. And it concerned both of the age groups, so the younger children and the older children. And as I said before, the analysis was done with the usage of this Godspeed scale. And this scale has those 5 major dimensions, which I kind of divided into 2 subcategories, 2 antagonistic categories for each of the dimensions. So for example, as you can see in the table on the right, the anthropomorphization was divided into treating the robot in human-like terms versus treating the robot as in machine-like terms, so as an object. And it was done same for every of those dimensions. So in the result, we had 10 categories we could put the data into. Yeah, and those are examples of how the data was classified. For example, we had this huge category, the major category of feeling safe in the company of the robot, and it was divided into feeling of safety or feeling of danger or feeling unsafe. And for example, the statement of a child which said, from what I've seen, he's a nice robot, was classified as feeling of safety. And such statements as, his eyes behind the curtain look so creepy, I'm terrified, or that's suspicious, referring to some behavior of the robot, were classified as unsafe. And moving to the results, I compared both of the groups, the younger and older children, and referring to the topic of anthropomorphization and animization of a robot, both of the groups treated the robot in human-like and animate terms. For example, they referred to the robot, they expected robot to answer, as their questions, they describe the robot in with some human characteristics or with some biological characteristics, but in the same time, the older children questioned robots' animacy and autonomy, usually by referring to the fact that robots are made by people and like they can't be autonomous because of that. The younger children treated the robot as an intelligent being, almost in the same way as they treated the tutor, their teacher, and the older ones very often questioned the intelligence of the robot. Both of the groups found the robot very likable. They stated that they find the robot very likable, but also the older children tended to be more careful with trusting the robot. And lastly, both of the groups are thought to find to have found the interaction safe. For example, both of the groups would approach the robot very closely, even when the human facilitator or parents weren't around them. But also the older children very often noticed some suspicious behavior of the robot, and they questioned its good intentions, as it was showed in the example on the slide before. And those results show that there may be some differences between the ages in the understanding of the phenomenon of the robot, and what are the characteristics that children ascribe to the robots as well. And I think that they may lead to some maybe further questions concerning where do these differences come from? Is it the culture thing? Or maybe the question of how should such interactions between children and robots be designed, for example, in some schools or hospitals or health centers, when we take into considerations facts as the feeling of suspiciousness towards the robot or questioning its intelligence or autonomy by the children. And then, thank you.
My name is Karolina, and in my part of analysis, I focused on unexpected robot behaviors. So behaviors that surprised children in some way. They belong to three categories. The errors would be a more human-like category for faulty robot behavior, so social protocol breaches or mispronunciation. Malfunction is a more machine-like term, so behaviors like delays in response or some other technical problems. And third category is robot sharing information about himself, so expressing some characteristics of his persona. What I mean by persona is this profile that we created in order to prepare for conversation with the children. So it has some more human-like aspects and some more machine-like. And from observation of children's reactions to those behaviors, there is a basis for the claim that both robot errors and robot sharing information about itself increased children's engagement in the interaction. For example, in case of errors, when in the play of charades, robot looked, let's say, one way, and a children on the other side of the scene was performing an action, and the robot guessed the action correctly. The children were very surprised, and they were asking experimenters about those inconsistencies. Or in case of the information from robot's profile, when the robot said he is vegan, children were asking further questions about this topic. For example, does he like hot dogs, or why is he vegan? And all those behaviors sort of can be interpreted as increased social engagement with the robot.
In case of malfunctions, movement-related malfunctions were increasing children's engagement, so also stimulating children to asking further questions about robots' movement abilities. However, delays in response were met with slightly different reaction pattern. There was age difference. Older children were sort of patiently waiting for robots' response, and younger children were starting to get distracted or bored. They were shifting their gaze away from the robots. They were starting to move a little bit in their seats. Therefore, if we would like to consider those imperfections in robot behavior as something positive for the interaction, then this age difference would have to be further investigated. And in conclusions, all of our 3 research threads revealed some sort of age differences. First observation, more of a methodological manner, would be that there is a need for choosing age-appropriate tools for evaluating children's expectations towards the robots, and also background of the children is very important. And the second observation concerns children's mental model. There are different patterns of creating this model for older and younger children. In our study, older children tended to treat the robot more machine-like, and younger children were prone to anthropomorphization. And the third observation, that there was a different pattern in reaction to the delays. However, more general sort of observation here would be that not all imperfections are bad in human-robot or child-robot interaction, and they may have some positive influence on children's engagement in the interaction with the robot. And that would be all. Thank you all for listening.